What happens after a major earthquake? Aftershocks, and some of these not mild. Can you imagine life after a wrenching pole shift, where the ocean rifts have been ripped apart to the extent that the oceans of the world dropped in sea level some 16 to 20 feet worldwide? What happens to cause aftershocks, which we are still experiencing from the last pole shift? After a pole shift, the plates come to rest, but there are inequities where pressure is constant against this or that point. The weight of one plate pressing against another, or pressing to move in a direction. They are restless in this regard, a long way from quiescence. They are held together by friction along the plate edges, or where they lay atop one another in the case of subducting plates. As any engineer will tell you, bridges and skyscrapers and that expensive new car you purchased will last only so long. There is wear and tear, stress fractures, changes in the chemistry of supporting structures over time, and finally, snap. When a snap or earthquake occurs, the plates move to a new position and once again the process starts. Beyond aftershocks, there is the effect of what is termed near-Earth asteroids, dragged into the vicinity of Earth by a close passage of Planet X, where they follow the planet as it comes through the asteroid belt and then get pulled into some sort of orbit that includes Earth. Objects viewed from Earth are relative in size, in that a distant Mars can appear tiny, but a close asteroid can loom large. Meteors are described as shooting stars, or flaming objects streaking across the skies on their way to a thud on the ground, somewhere. It is not in the recent documentation of man that larger objects have fallen to Earth, but those events were recorded after the last pole shift, as Velikovsky has documented. Since the greater part of Earth is water, and many places are virtually uninhabited in vast deserts or the frozen wastelands of the poles, the likelihood of a large object dropping near a civilized and populated area is slight. Such a disaster happening, even in a slightly populated locale, would wipe out all witnesses close by, leaving only those at some distance as witnesses. Space shuttles and satellites put up by man regularly flame upon re-entry, so heat from the friction against increasing atmospheric pressure is obviously a factor. Lightning occurs during simple thunder showers due likewise to friction, where the electronic charge between air masses becomes different and is adjusted. Now, why would such lightning not occur during the fall of a minor asteroid to Earth? Is friction and heat and all the electronic repercussions that come from that in the atmosphere not present, as they are during thunderstorms? What are the plate impacts that occur when a minor asteroid does not burn up completely upon falling to Earth? If an earthquake can result in many aftershocks, is this not a shock? Are nearby volcanoes subject to pressure, and the lava beneath them not activated? A thud on a plate results in immediate pressure from above on the plate, which has an immediate effect upon any volcanoes subject to lava pressure from below on that plate. The pressure on the plate likewise changes the dynamics on the tenuous plate edges, so that quakes from this source occur too, along with the aftershocks. This is what Velikovsky documented in the very true reports from several centuries after the last shift. The forthcoming pole shift in 2003 is less likely to invoke minor asteroid passages of this sort. But as the core will shift farther without being drawn into an immediate alignment jerk, it will change the geographic in a more radical fashion. In addition, the sloshing of the oceans will create greater flood tides than the prior shift. Thus, this pole shift is anticipated to have a greater impact and die off than the prior.